Today I am going to show you an example of Modbus TCP communication between an Omron PLC and Beckhoff PC. I needed a video like that as an example, but I couldn't find something like that, and that's why I'm recording this video. I will just try to show you my case, and actually it's kind of obvious why there's not much example about that, because both PLCs, Omron and also Beckhoff, has EtherCAT communication capability, and that's EtherCAT is way better than Modbus TCP, and that's why people do not use so much Modbus TCP communication in these PLCs. Okay, whatever. If we come to the example. Okay, firstly I want to show you both of our codes when we do not run them. In TwinCAT3 site, in TwinCAT3 site, first we done our declarations. This is for Modbus register function blocks, and like you all know, to communicate with Modbus protocol in Beckhoff PC, you have to address your variables into memory words to make them open for Modbus communication, and these sections for that, and also our Modbus functions again for the writing our coils, and our variables for the state machine, and also again for Modbus. These are not much important, same thing above, like above. Yes, and these are the main codes. In here you can see we make our necessary conversion. Our button 1 for Modbus and button 2 for Modbus is the Boolean variable, and we have to convert them to a suitable format for the Modbus function, and which is bytes. So we use bool to integer and integer to bytes conversion. Also same idea for the potentiometer. And I want to show you the system for better understanding. And this is my Beckhoff kit. Like I said, there's 2 selector switches and 1 potentiometer, and I want to control a winder unwinder system with them. And this is my plant. There is a one 3-phase asynchronous motor and also servo motor behind them, and I want to control this system. Like you see, this is a DC motor inverter and also a servo driver. Whatever, you get the idea, I believe. And we called our Modbus functions first for first selector switches, second one, and for potentiometer. I will explain them more details. Yes, and in the Sysmac Studio site, you can see this is our main automation scenario. This is our Modbus function server block. I will explain it also. And these sections are not much important. Like I said, there is a one MX inverter and also KN04 inverter to control, and the idea is like that. Now I will run both of these codes and show you how things are going. In my cases, in Beckhoff site, I have 2 selector switches connected to Beckhoff PC's digital input module, and also have 1 potentiometer as analog input connected Beckhoff PC, and I'm trying to transmit them to Omron PLC with Modbus TCP communication. You can see this is a value of the potentiometer and value of the first selector switches and the second selector switches. Okay, if we come to Omron site, As you all know, Omron PLCs or Sysmac Studio doesn't have the built-in Modbus functions. You have to call the Omron's local technical support desk and ask for these function blocks to achieve Modbus TCP communication with your Omron PLCs. But as this is not something so much official, it's a little bit hard to use because there is no example about these blocks, and it's also can be seen to double click on them. You can see its SD codes here, and I really do not recommend you to try to change it if you are not a professional about Modbus TCP. Okay, this is our block, and in my case, my Omron PLC is the Modbus server and Beckhoff PC is Modbus client. As you all know, in Modbus communication, it reads data from the memory area and also writes it to the memory area, and it writes them as the array of blah blah, but it depends on what data is. In my case, it's word for the potentiometer and boolean for the selector switches. Okay, if we come to the Beckhoff side, which is, I believe, a little bit more important. These are not important. Okay, this is our first Modbus TCP function blocks. Function block write coils. In my example, as you all know, in Modbus TCP communication, we can write only one data in the exactly same time, but I have to send 3 data in the same time, but that causes an error if I'm trying to do that. And to solve that, I created a state machine. You can see it. I'm writing the first selector switches boolean data in here, and second selector switches boolean data in here with the same function blocks, and at last I'm writing the potentiometers data in here, and it goes to the infinity. I know that's not the optimal communication for Modbus TCP. There are also better functions to do that, like write single coils, or write single register. But I solved it like that, and in my case, this code worked, and I didn't change it. In Modbus TCP, you know, these are my Omron PLC's IP address and TCP port, unit ID, blah blah. Quantity is the length of our data, which is 1 for a Boolean variable. Modbus address is the address of the memory address of your Modbus servers. It has to be in. Let's check it. This is for the first selector switches, and if we check the coils array, let me show you it. Yeah, that's it. Okay, we can see the first element of the array is at the zeros address, and that's why we wrote 0 in here. Length is also, it's obvious, size of our data. Address is a pointer of our first selector switches Boolean variable. These are not so much important. You can see much more detail in the info.sas.beckhoff.com about these function blocks. But I know it's not always enough. That's why I am recording this video. Okay, for the second selector switch Boolean data, you can see the same thing. The only differences is our Modbus addresses, because I have to write it to the first Modbus area. And at last, for the potentiometers variable, we can see everything is also the same. Just our length is 2. We use the size of function to arrange it. And our Modbus address is 1, because we can see our registers arrays addresses starting from the 1. And that's why we are writing it to here. And that's it. We can control our system like that. In my case, I am trying to drive two motor, which is one is a servo motor and one is a 3-phase asynchronous motor. I can show you the image of it. This is not a very good image, I know, but it gives the idea about what's going on. These are all selector switches and potentiometers. It gives our 24 voltage, and we can get it at the Beckhoff's EtherCAT coupler, and with EtherCAT it comes to our Beckhoff PC, and Beckhoff PC do its job, and with Modbus TCP it sends our data to the Omron PLC, and Omron PLC do its own job and sends this data with an EtherCAT to our Omron NX ACC 202 EtherCAT coupler, and these component also sends this data with EtherCAT to our MX2 inverter or KN04H servo inverter, and the system is working like that. There is also an HMI screen, but it's not important for now. That's it. It's like that. I'm not a professional teacher, especially about these topics, I know, and I am just trying to show you my case as an example. I hope it helps you in your problems. If you have further questions, you can also contact me. There's no problem about it. Okay, thank you for watching. I hope I helped you to solve your problem.